morning, people. We're back again. We're going to briefly look at an outline of epithelial tissue, the basic cells that make it up, and the various subtypes of epithelial tissue. Once again, we're going to go back and review the slide, which is really important. But before then, I want us to understand the concept behind it. So, epithelial tissue is a type of connective tissue, and it surrounds the linings of the body. Literally, some people define it as covering the body. You may notice that your skin on the outside continues with the inside of your mouth. In actuality, the inside of your mouth is part of the outside of your body, just that it's pulled inside. Alright? So epithelial tissue lines the outer part of the body and the tubes of the body, basically. Now, there are three types of epithelial cells. You have your squamous, cuboidal, and columnar. Squamous is flat. Cuboidal is just like an ice cube. And columnar is like a column. Now, these three types are arranged in various patterns to achieve a particular goal. Sometimes they are arranged end to end, in which case it's said to be simple. Or they could be stacked on top of each other, like a social strata, in which case they are said to be stratified. So like in a social strata, you have people who are super rich, people who are rich, people who are upper middle class, middle class, lower middle class, upper poor, middle poor, lower poor, and those who are like, oh, I need major help. Alright? Social classes. Same concept with the issue of layering the cells on each other. They are stratified. Now, quick question. Let's say between a stratified layer and a simple layer, if I wanted something to pass through real easy, between the simple and the stratified, which one will let something pass through easily? The simple, right? Awesome. Now, what if I wanted something that could withstand a lot of friction? Stratified, because when I'm scraping away, I will be scraping away only at the top layer. There'll still be some bottom layers there to protect the body. Now, the more layers you have, the less absorptive it is. And the more it is relevant for either storage or to resist friction. And in terms of absorption, single layers, and in terms of the concentration of what is being absorbed, the more concentrated or more toxic that particular thing is, the more you have to use thicker sized cells. So let's say in the capillaries and the alveoli of the lungs, air is not toxic, and you want to absorb a lot of it. So you want to use simple squamous epithelium in those areas where you want to absorb oxygen and exchange nutrients real quick. Whereas in places where you need to store certain secretions that could be toxic, you don't want to use simple squamous. You want to use simple cuboidal, as does occur in some endocrine organs and the kidney tubules, where the urine is produced in the tubules and it moves along. But it has to be brought into the kidney tubule. So you want to have one single layer for easy absorption and secretion, but you want to have a particular set of cells that are strong enough or thick enough to withstand the toxicity of the pee. Now, simple columnar on the other hand, you want to have one layer for absorption, but what you are absorbing from is like super toxic, and it's going to take a gradual long time to move along, as happens in the digestive tract. So you have simple columnar within the digestive tract just by virtue of that function. One layer for absorption, but you need this long, thick cells because the intestinal contents are very, 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 very toxic in comparison to air. So from that concept, you can picture, where am I going to find which set of cells? Stratified squamous, areas of high friction, outside of the body, the rectum, the cheeks. Simple squamous, I want something to be absorbed real quick that's not toxic. The alveoli of the lungs, the capillaries, where you want to exchange nutrients real fast. What about when I'm making pee? Pee is toxic, yeah, but I need to absorb some and secrete it out in the kidney tubules. The same thing for some endocrine organs. Then in the intestines, hydrochloric acid from the stomach. Now that's like super toxic. So I'm going to need simple columnar cells to allow absorption, but they have to be strong to withstand the toxicity of the intestinal contents. Now, another thing about the simple columnar is they have an added adaptive feature where they have certain specialized cells that make mucus called goblet cells. The mucus is to further help to reduce the toxicity and to encourage the movement of the intestinal contents. Now, there is a specialized type of columnar cell called pseudostratified. Let me call it specialized set. Specialized epithelia. Epithelia. We have one pseudostratified. Two transitional. Alright, pseudostratified, it occurs in the respiratory system outside of the alveoli. It looks like it's stratified, but the difference is that the nuclei of those cells, they're not at the same level. That's probably what makes it look stratified, but in actuality, they are actually just staggered amongst themselves. So it actually is a simple columnar epithelium that appears falsely stacked on each other. As I said, it occurs in the respiratory tract. At the upper surface of it, it has cilia. And intermingled between the cells, you have mucus-producing cells called goblet cells. Now, as a brief anatomical description, pseudostratified is present in the trachea and the bronchus. Its job is to produce a lot of mucus and the cilia to push up the mucus back up to the top of the throat, which is the reason why we do something like this, where we have something in our throat and we have to swallow it into our esophagus. What that is the mucus that was produced, as we're breathing, the mucus traps dust particles and the cilia pushes it up to the top of the trachea, and eventually it irritates the back of our throat, and we do that and we swallow it. Now, in people who have certain conditions that affect the cilia functioning, for instance, people who have COPD, specifically chronic bronchitis, the cilia isn't able to push up the mucus. Therefore, the mucus gets stuck in the airways, and it can cause a whole lot of mess, part of which is a reduction in their ability to breathe in adequately. It can also cause bad breath and a bunch of other issues. So much for pseudostratified. Now, transitional epithelium is another type of specialized epithelium that is present in stretchy organs that hold on to fluid, specifically the bladder and the ureters. Now, when you look at transitional epithelium, it looks like you're moving from simple squamous to cuboidal to columnar, and you're not really sure what specific type of cell is there. And the reason why is because, as I said, it's designed for stretchy organs that are meant to just hold on to fluid for a while and let it out. And that's about it for the epithelia. Once again, you organize your thoughts. You think of the three basic types of cells involved in epithelia, and then you ask yourself, why should they be stratified or simple? If it's stratified, you're going to have less absorption and more protection. If it's simple, you're going to have more absorption and less protection. And if it's simple, if there's a lot of absorption, the particular type of cell you want to use will be determined by the toxicity of what is being absorbed or secreted. Air is less toxic. pee is somewhat more toxic than air, but intestinal contents is like super toxic, as in hydrochloric acid. And of course, as you're going along, the more toxic the substance is, the more mucus you would have present, so therefore you'd have more goblet cells. Now, we also talked about the specialized epithelia, the pseudostratified and the transitional, and we mentioned where they are found. Now, with that in mind, you can answer the question, where do I find this particular epithelium? In our next few videos, we're going to look at certain slides and we're going to make reference to these sub-classifications to help us remember them. So that's all for today. We're going to quickly talk about muscles in the next video. Thank you.